Hi guys, welcome to yet another video of Code from Scratch. So proud of you for showing up today, and also we have finally moved to the hard level questions. How do you feel? Let me know in the comments. Was yesterday's video clear to you or not? If not, then today we are going to pick up the first hard level problem of binary search, and we are going to see how this fits the pattern. If you have not seen the last video, I would highly recommend you to watch that first so that you know you are completely ready to pick up the hard questions. If you have not watched, it's fine because we're going to be discussing the question today. We are going to understand that why this question belongs to binary search concept. Okay, so without wasting any time, let's get started. So in the question, we are given n books. Okay, so if we see at this example, n is 4 and these are the books that are given to us. And every ith book has ai number of pages. So every book has some number of pages. Here you can see the first book has 12 pages, the second book has 34 pages, third book has 67 pages, and so on. Now you have to allocate contiguous books to m number of students. So here in this example, there are 2 students, m number of students, and we have to allocate contiguous books. What does that mean? So if you see in the example over here, like here you can assign the books like this, that okay, the first student will get 12 pages and the second student will get rest of the 34 plus 67 plus 90 pages. Another way that is possible is the first student will get 12 plus 34 pages and the second student will get 67 plus 90 pages. Another way that is possible is the first student will get these many pages and the second student will get these many pages. But it should always be contiguous. You can't do like, one student will get 12 plus 67 pages. You can't do that. You have to pick contiguous books. So you can't pick like first and then third book or first and fourth book. You have to pick like first, second, third, or just first, second, or just first, second, third, fourth, or just first, like that. Okay, it has to be contiguous. So this is why these questions are, about details. You have to notice every single word over here. Okay, then what is given? There can be many ways or permutations to do so. So there are many ways in which we can give. We discuss the ways over here. Okay, in each permutation, one of the m students will be allocated maximum number of pages. Out of all these permutations, the task is to find that particular permutation in which the maximum number of pages allocated to a student is the minimum of those in all other permutations, and print this minimum value. Okay, I know this becomes a bit too much. So let's write the details down and let's see what's expected. Okay, so we are given n books. So the array is of length n. Okay, and we are given m students. Now we have to divide the books. Okay, now suppose let's say there are 2 students. Let's take to understand. Okay, see, suppose there are total number of x pages are present in all the books combined. Okay, now say one student gets these many pages. Say there are y pages over here. So the second student will get x minus y pages. So you have to make sure that the maximum pages that a student gets is minimized. So this problem is of minimization problem. So in the last video we saw that we will either have to maximize something or we will have to minimize something, right? So what is this problem? Is this a maximizing problem or is this a minimizing problem? Let's look at that. So here it is given that something is the minimum of those. Okay, so what do we have to minimize? We have to minimize the maximum number of pages allocated to a student. But this is a minimization problem. See, this is a very important point. Do we have to minimize or do we have to maximize? And what do we have to minimize or maximize? We have to minimize here, and what do we have to minimize? We have to minimize the maximum number of pages allocated. See here, if we take these examples, here the pages allocated were 12 and 34, 67, 90, right? What is the summation of 34, 67 and 90? 34 plus 67 plus 90 is 191. Okay, so here the maximum number of pages that are allocated to one particular student is 191. In this case, if we see, it is 12 plus 34, which is 46, and here it is 67 plus 90, which is 157. So here the maximum number of pages that are allocated is 157. Similarly, here the maximum number of pages that are allocated are 113. So we have to make sure that the maximum number of pages that are allocated is minimum. So here our answer should be 113. Okay, now let's come back and try understanding from our diagram. The same thing we can understand from the example given to us also. So these are the 4 books that are given to us. Okay, now if we divide the books at this level, then what are the number of pages that each student gets? So first student gets 12 pages, the second student gets 191 pages. Similarly, if we divide over here, the first student gets 12 plus 34, which is 46 pages, and the second student gets 67 plus 90, which is 157 pages. Similarly, if we divide over here, the first student gets these many, which is 113 pages, and the second student gets 90 pages. Okay, so what is the maximum number of pages that a student gets in these particular possibilities? Okay, so here the maximum value is 191, here the maximum value is 157, and here the maximum value is 113. So now out of these 3 values, we have to minimize. Again, this is a minimizing problem. Okay, what are we minimizing? We are minimizing the maximum number of pages that a student gets. Here, see, these are the possibilities. Here the maximum number of pages that a student gets is 191. Here the maximum number of pages that a student gets is 157. The maximum number of pages that a student gets is 113. Now we have to minimize it. What is the minimum of these 3 values? It is 113. So that is why a correct answer for these 3 possibilities will be 113. Now other doubts that you can have is, why didn't we divide like this, that one student gets no pages and the other student gets all the pages, like this or like this. So why have we not taken these possibilities? For that, let's go back to a question. So there are some more conditions given to us. One condition is that each book will be allocated to exactly one student. So you can't do like, if there are like 12 pages in a book, we are going to divide it. We are going to go like 6 pages to one student, 6 pages to another student. You can't do that. That is one thing that is given. Each student has to be allocated at least one book. That is why we did not take the case when 0 books are given to one student and all the other books are given to the other student. So that is why this statement is also very important, that each student has to be allocated at least one book. Now we have to return -1 if valid assignment is not possible, and an allotment should be in contiguous order. See the explanation for better understanding. Let's revise the question once more, because till now we are discussing the question only. After this, we will see how this fits in the pattern and why this is binary search question. Okay, so let's revise the question quickly. There are n books given to us, okay, and every book has some number of pages. So these are the books given to us. Each book has some number of pages. Now it is given that students have to be allocated in contiguous order. Okay, so you can either give like this, or like 2 books, or like 4 books, or just 1 book. So contiguous order. Then it is given that each student has to be assigned at least 1 book. That is given. Now we have, what is given to us? We have to minimize, and what do we have to minimize? The maximum number of pages allocated to a student. Okay. Now that we have understood the question, let's try seeing that why this is a binary search question. Okay, so what are the pointers that we have? The first pointer that we have is that we are minimizing. Okay, what are we minimizing? What is the value v that we are minimizing? That is the maximum number of pages that a student gets. Okay, so we are minimizing this value. Now what's the first thing we should be doing? We should be seeing the search space. So basically we are actually looking at what are the possible values of v. Basically, what are the possibilities of this maximum number of pages that can happen. For this, I want you to pause and actually think that what is the maximum number of pages. So what is the minimum value of this and what is the maximum value of this? So that is the search space that we will be looking at. Okay, so the minimum value can be the maximum number of pages that is present in a book. Let me talk about this why. And this will be sum of pages, total number of pages. Okay, why is this? Okay, so we have to find the maximum number of pages v. Okay, suppose we do that, we assign 1 book to each student. Say we assign 12 to one student, we assign 34 to other student, we assign 67 to one student, we assign 90 to one student. Okay, so this is one case where we will assign one book to each student, because each student has to be allocated at least 1 book. So what is the maximum number of pages in this scenario? It will be the maximum number of pages that is there in 1 book, right? So at least 90 pages will be given to a student. Okay, so this is the maximum value that will always be there. Like this is the minimum possible value of maximum number of pages. Let me say it again if it's not clear. See, there are 4 books given to us, 12, 34, 67, 90 are the number of pages. Now we will try to make sure that we give each book to one student. That is the best possible case to minimize this value. Now in that thing also, at least one student will get this book which has 90 pages, right? So in that case also, say one student gets 12, 34, 67, 90 like this. What is the maximum number of pages that a student has gotten? That is 90. So at least this value will always be there. Okay, and what is this value? It is the maximum of the number of pages of all the books that is present to us. Okay, again, if it is not clear to you, I am repeating it again. So every student will get at least one book. Okay, we have to make sure that we have minimum number of pages for each student. Okay, because we have to minimize this maximum number of pages. Okay, so what is the maximum value that this can go to? That is 90. So this is the minimum value of the search space. What is the maximum value? The maximum value is if all the pages are given to one student. Say if m becomes equal to 1, then all the pages will go to one particular student, right? So in that case, the sum of the pages is the maximum value that will go. To quickly revise this part, what is the value that we are minimizing? We are minimizing the maximum number of pages that a student can get. So now what is the search space of this value v? Basically, what is the minimum and the maximum possible values of this value v, where v is the maximum number of pages. Okay, so every student will get at least one book, and every student will have at least that many number of pages that are present in one book, right? So this 90 pages, at least one student will end up getting. Okay, so this is the minimum value that maximum number of pages can have. What is the maximum value? Maximum value will happen when all the books are given to one student itself, right? So that will be 12 plus 34 plus 67 plus 90. Now you are saying that, now you might think that m value might be greater than 1. In that case, this will not always be the maximum value, which is true. But let's assume that, okay, m is equal to 1, and let's do this. Now, even if m is equal to 2, say, the number of pages of books that was given was 34, 67, 90 and 1. Now, one book we can go give to one student, and these many books we can give to another student. That is also possible, right? So, to avoid, calculating this again and again, that what is the maximum value that is possible, let's just take the value of m equal to 1. And let's assume that, okay, all the students are going to get one student is going to get all the books, because this is just a search space. We are not saying that, okay, this will be the answer or this will be the answer. We are saying that our answer is going to lie in between this. Now, this can be a possibility. This can be a possibility, say when m is equal to 1, or the values in between can be the possibility. Okay, so this much you have understood. Firstly, we are minimizing this maximum number of pages. We have understood what is the search space of this value v. Now, second thing that we have to see is that what are the conditions that are given to us. The number one condition that was given to us is that there are m students. Then there were some more conditions given that, okay, each student has to get one book at least. You can't divide the number of books into number of pages. All those conditions are given to us. Okay. Now, what did we see? We had to actually see that, okay, why binary search can be applied to this. Why can we be sure that, okay, if we increase the value from this, we are going to get the minimum value or we are going to get the maximum value? How can we be sure that, okay, we can reduce our search space to either first half or the second half? Now that you have understood the problem and you have understood the search space and everything, some of you might actually be thinking that it is better to do the problem with recursion or dynamic programming. See, in that case, the solution will be order of n square. That is the best thing that is possible. But binary search will give a much better efficient solution, and in interviews and all you'll be expected to talk about binary search. This might take actually a lot of time if you end up talking about recursion, dynamic programming. Once you understand this pattern properly, when you see a problem itself, you will be able to tell that, okay, this is a binary search problem, and you will not waste your time talking about recursion and dynamic programming at all. So if any of you is thinking about recursion, dynamic programming, just try to forget about it for now, because we are understanding a new concept. We are trying to fit this problem into binary search. Once you do that, okay, we can see that, okay, this is more efficient, and you'll be able to identify the binary search problems very, very fast. Now let's try applying binary search and see how it's going to work, how we are going to be able to reduce the search space. Okay, so we are minimizing this value, maximum number of pages, and this is the search space that we have, 90 to 203. Okay, so 90 is the minimum value that maximum number of pages can go to, and 203 is the maximum value of maximum number of pages it can go to. Okay, So let's take a middle value right now. The middle value that we have is say 101. Okay. Now we will see whether we can assign m students. So m over in this example is 2. Okay. So we will see whether we can assign 2 students the books such that 101 is the maximum value that a student gets, the number of pages. Okay. So we had the arrays 12, 34, 67 and 90. So we try assigning the books now. So the first student we assign 12 books, 12 pages. Okay. Then we come over here. We see, okay, 12 plus 34 is less than 101. So we assign 34 pages again to student 1 itself. Okay. Then we come to the 67. So if we again give 67 to the first student itself, then the number of pages that the first student will get is 12 plus 34 plus 67, which actually becomes more than 101. But we want to see that if it is possible to have the maximum number of pages to be 101. So what we will do is, instead of assigning it to the first student, we will assign it to the second student. Okay. Then after that we will go ahead and see, can we give the second student these 90 pages also. If we give this, then 67 plus 90 will become 157, which will be more than 101. And we want that the maximum number of pages that one student gets is 101. So we can't do that. So what do? We end up assigning 90 pages to the third student. But it is given to us, the condition is given to us that m value can go to maximum 2. So maximum number of students that should be there is 2 only. So this is not a feasible solution. So now we have to see whether we should take a value which is less than 101 or which is more than 101. Okay, that is what we do in binary search. Now think about it. If for maximum number of pages for 101 itself, we were not able to assign all the books to students, right? So we have to make sure that, okay, the number of pages that we can give is more, right? Because if we assign any value that is less, suppose we assign the value say 100, okay, in that case we will end up needing more number of students. So as we reduce the number of pages, we are going to end up increasing the number of students. And that is the whole concept of this question. See, if we reduce the number of pages, we are basically increasing the number of students. And it is given to us that there are m students. So maximum value that the students can go to is m. So to reduce the number of m students, we have to increase the number of pages. So that is why our now search space reduces to this. And we don't check for these values at all. And this is why we can apply binary search. So let's take one more iteration to understand this. Now our lower value has become more than 101. So we know that for 101 also it is not possible. So we will move our lower value to say 101 plus 1, which is 102. And we will move our higher value, the maximum value, to 203. So the mid value will be 102 plus 203 by 2, which is actually 152. So we now try to see if we can assign maximum number of pages 152 to 2 students. Okay, so let's try doing that again. So now let's say the first student we will give 12 pages. Okay, then we come to 34 pages. Can we give 34 pages to the first student itself? So 12 plus 34 is 46, which is less than 152. Then we try giving 67 pages to the first student itself. Can we do that? So 12 plus 34 was 46 plus 67 will become 113, which is still less than mid. So okay, we can actually go here because this is a possible solution, right? We have to make sure the maximum number of pages that a student gets is less than 152, less than or equal to, and which is true, so we can assign. But when we add 90 over here, that will not be possible. So that is why instead of adding 90 over here, what we are going to do is we are going to give the 90 pages to the second student. So this is a possible solution. Okay. Now this is a possible solution. But is this the answer? So we are at 152 over here. Is this the answer? No, because we have to minimize. Okay, this is a minimizing problem. We have to minimize the maximum number of pages. So in our next iteration, what we are going to do is we are going to move our search space from 102 to 151. Because 152 is a possible solution, yes. But since we have to minimize it, we will now move our search space to 102 to 151, because if we move over here, we are actually just increasing our answer, but we have to minimize our answer. That is why we are going to move towards the left side. And this is why we can apply binary search. We can keep dividing our array into half, and we will keep reducing our search space. So let's quickly revise this. See, if it's not clear till now, it's fine, because tomorrow we'll be going to write the code and it will be completely clear. But let's quickly revise it. So it is given to us that we have to minimize the maximum number of pages that we can have. Okay. Now we have a search space for that. Now we will take a possible solution and we will put this condition m equal m students. So what we will do is we will have our array, right? So our books array we will have. So this is our search space basically. Okay, so instead of that, now we will consider the book array and we will start assigning these students these many number of books. Okay, so this is the maximum number of books that we are going to assign. Now we will see whether this is a possible solution or not. If this is a possible solution, then it is well and good. Now, and we have to minimize it. So we are going to move our search space towards the left side. If it is not a possible solution, then we know that, okay, we have to increase the maximum number of pages that a student can get to reduce the number of students. So for that, we will move our search space to the right side. So this is how we will keep moving our search space to either left side or right side to solve the question. So now what I want you to do is, your homework is to try writing the solution yourself, to try writing the code yourself. If you are not able to write it, it's completely fine, because tomorrow we are going to be doing this together. I know this is a hard problem, but this is the first problem that you're doing. After this, when we do the rest of the questions, you will understand that, okay, all of them fall under the same pattern itself, and it's so easy to understand them. It's just that, this first phase will be a bit more harder to understand that, okay, why this question belongs to this particular pattern, how to identify what value we have to maximize or minimize, and how to do that. And once you can do that, once you're able to write the first code, you will be able to write the rest of the codes. And trust me, these questions are asked in Google and Amazon. So try watching the video again, try understanding it again. It will come to you, it will get to you once. Okay, and it will be completely clear. If you have any doubts, let me know in the comments. I will go through the comments and then record the code part of the question. Okay, so I'm not recording it right now because I want to answer all the doubts that you will have. So that is why I want you to mention all the doubts that you have, so that tomorrow's videos, when I record, I already know that, okay, you have these doubts and I can clear it tomorrow itself. So see you tomorrow.